Now that we've covered all of our theorems, I'm going to go ahead and illustrate a couple important things that have come out of all these different theorems, things that you should know for secants and tangents when they relate to circles in geometry. So let's begin with this, that when you have a secant meeting a tangent, the angle that's created there, so in this case the angle that I'm referring to is angle EFG, this angle right here is actually equal to 1/2 the arc length created by that secant-tangent intersection. So this arc length right here. That's going to be true for all secant-tangent intersections. And it's also true for the opposite side here. So this angle right over here is going to be equal to 1/2 of this arc on this side. So let's try a practice problem with this concept. In this problem, I'm going to tell you that the angle EFG has a measure of 76 degrees, and what I'd like you to do is solve for the arc FG. Now notice I'm asking you to solve for this arc, and using the theorem that you know, we could solve for this arc. Well, remember that we know that a circle is a total of 360 degrees, so we will be able to solve for this arc on the left once we solve for the arc on the right. According to this theorem here, since measure angle EFG is 76 degrees, that's going to be equal to 1/2 of that arc that we're looking for right here, FG. So I'm just going to write that 1/2 of arc FG. So I want to solve for arc of FG, so what I'm going to do is multiply by the reciprocal of 1/2, which is 2/1, and I'm going to do that to both sides. So basically we're just multiplying the left by 2. 76 times 2 is 152 degrees. So that must be equal to this arc right here. We're going to call that FG, and it's really more of the minor arc that we're referring to. But we want to know this dark blue FG. Well, we know that a circle is a total of 360 degrees. So we're going to subtract the side that we solved for, this arc, that was 152 degrees. And what we get is that that arc has a measure of 208 degrees, that dark blue arc right there. Now let's take a look at another interesting concept. In this case, measure angle FVS. So the angle that I'm referring to right here is right here, FVS. That's actually equal to 1/2 of the arc length FS plus the arc length UT, so directly across from that. And that's always going to be the case. So for example, this measure right here, FVU, is going to be 1/2 of this arc, FU, plus arc, ST. So let's go ahead and do a practice problem around that. So what I've provided is that arc length FS has a length of 53 degrees. And arc length UT has a length of 175 degrees. And what I'd like you to do is to solve for measure angle UVT. Now remember, this formula helps us solve for angle FVS, which is right here. But FVS and UVT are congruent because of vertical angles. So we can solve for angle UVT. We know that measure angle UVT is congruent to FVS, so we'll just plug it back in for FVS in this formula. So angle UVT is equal to 1/2 of arc FS, which is 53 degrees, plus arc UT, which is 175 degrees. So angle UVT is equal to 1/2 of 228 degrees. And half of 228 degrees is 114 degrees. So 114 degrees is equal to angle UVT. Now I just want to take a moment and summarize some of the things that we've learned and do a few more practice problems. Now the theorems that I'm about to show you, you've actually already learned the basic information around them, but they're written in a different way. And so what I'd like you to do is learn to recognize them in this way as well, so that you can apply these in the practice problems. So in the figure on the very left, we have a secant PR and a tangent RS. And the angle there, PRS, is going to be equal to 1/2 of the arc PS, which is right here, minus the arc QS, this interior arc right here. Now let's take a look at the middle theorem, that this angle, measure angle EGT, is actually going to be equal to 1/2 of these two arcs, TE, the major arc piece right here, the larger, minus HF, the smaller. And you can see that GT and GE are both secants. Then we have measure angle TUV, which is right here. And that's going to be equal to 1/2 this major arc TWV, so all the way around here, minus the minor arc TV. And both UT and UV are tangents to this circle. Now notice the commonality between these three formulas, that you always take the larger arc and subtract the smaller arc from that. Then take half of that answer, and that's equal to the angle that's created here. The angle on the left between the tangent and the secant, the angle in the middle between the two secants, or the angle on the right here, TUV, between the two tangents. Just remember when faced with problems like this in this chapter of geometry that you always want to take half of the difference of the larger arc minus the smaller arc, no matter what you're dealing with. A tangent and a secant, two secants, or two tangents. So let's do some practice problems for each of these. We'll start with the tangent-secant combination here on the left. I've told you that measure angle PRS has a measure of 44 degrees, and the smaller arc here, QS, has a measure of 65 degrees. I'd like you to solve for the larger arc, PS. So let's use the formula from above, that angle, PRS, which is 44 degrees, is simply equal to half the larger arc, which in this case we'll call X, minus the smaller arc, which is 65 degrees. So 44 degrees is equal to 1/2 of X minus 65, and what we want to do is multiply now by the reciprocal of 1/2 on both sides of the equation. So essentially we're going to be multiplying by 2 on both sides. So 88 now on the left, 2 times 44, is equal, the 1/2 and the 2 are going to cancel, so that 88 is going to be equal to X minus 65 degrees. So what we want to do to get X alone is to just add 65 to both sides of the equation. So X will be equal to 153 degrees. And that's measure PS, that arc right there. So I'll just write that X as arc length PS. Now let's take a look at the middle problem. In this case, we've been given the large arc TE, which is 175 degrees, and the smaller arc HF, which is 57 degrees, and we want to solve for that angle TGE. So we know that that angle, and I'm going to refer to it as X for the moment, is going to be equal to 1/2 of the large arc, 175, minus the small arc, 57. So we have X is equal to 1/2 of 118 degrees, which is 175 minus 57 degrees. And half of 118 is 59 degrees. So in this case, X must be equal to 59 degrees. And remember that X is actually angle EGT. So I'll write that in here for X, angle EGT. Now let's move on to our last problem. This one involves a little bit more algebra. In this case, that angle TUV is equal to the larger arc TWV minus the smaller arc TV. Now what you may have noticed in this problem is that I only gave you TV being 110 degrees. And I'd like you to solve for TWV. Well, remember that every circle is made up of 360 degrees. So if TV is 110, then TWV must be 250 degrees. So that's a way that somebody could make this problem appear to be more complex than it actually is. So let's go ahead and solve now. We know that that angle, TUV, is 5x plus 10. And that's equal to the major arc there, TWV, which is 250 degrees. So half of 250 degrees minus the minor arc, which is 110 degrees. So we have 5x plus 10 is equal to 1/2 of 140 degrees, 250 minus 110. And half of 140 is 70. So 5x plus 10 is equal to 70 degrees. So now what we want to do is solve for x here is to subtract 10 from both sides of the equation, and we'll get 5x is equal to 60 degrees. Now we just want to divide by 5 on both sides of the equation. When you do that, you'll get that x is equal to 12 degrees. So we covered a lot of information in this tutorial about the chord-chord product theorem, the secant-secant product theorem, the secant-tangent product theorem, and then all these little pieces of information that result because of that, these little different formulas that we've covered. What you want to do is go and seek these problems out in your book and practice them. Just get used to how to manipulate these formulas, how to solve for pieces of missing information like we did in that final problem, so that you can actually solve these quickly, because they're kind of tedious and you won't have a whole lot of time on your exam to get through a lot of these.